of the basic PowerFlex architecture, components, nodes, and software interfaces. This includes whether the solution design requires networking provided by technologies. Also, the topic is designed to verify you know the different types of nodes that are used for the deployment models of the PowerFlex product. The main software interface that provides the maintenance and operation for the designed solution is PowerFlex Manager. The PowerFlex Management Platform 2.0, or PFMP, is the Kubernetes cluster that is installed on 3 management virtual machines in 3 cluster nodes to receive and execute configuration requests and modifications from PowerFlex Manager. Let's look at an example of a question asked for this topic. A customer has their own management services. They prefer to build their own environment and want a broader range of network options. Which PowerFlex offering meets their needs? Is it PowerFlex Rack, PowerFlex Appliance, PowerFlex Software Only, or PowerFlex Custom Node? The answer is PowerFlex Custom Node. A PowerFlex Custom Node is a single server that is either a storage or HCI node that provides the customer with the building block for a PowerFlex solution. Customers may prefer to build their own PowerFlex solution or supplement a solution. The customer only requires a good configuration design for the node to satisfy their need. By purchasing custom nodes, the customer can build the 3-node minimum required PowerFlex solution with the caveat that they can use their own managed services and network. The other PowerFlex products require a minimum of 3-node cluster design with specific management services, such as the PFMP 2.0. The Rack, Appliance, and Software Only have specific requirements for deployment that the custom node deployment does not require. Also, Rack and Appliance require a specific switch type to provide the networking. Those switch types are outlined in the PowerFlex 4.x compatibility matrix document. Our second topic is around PowerFlex solution design. No 2 customers are exactly the same, and so no 2 PowerFlex designs will be the same either. In order to design a solution that meets the specific needs of each implementation, you need to have an understanding of what situations each PowerFlex solution is designed to meet. This is what the PowerFlex solution design section of the exam is designed to test. This section of the exam will present you with different customer scenarios and test your ability to choose the correct. It also tests you on the use of the tool sets used to capture and then size the implementation appropriately. Here's an example of a question asked for this topic. Which node type supports AMD processors? Is it R6525, R650, R740XD, or R840? It's the R6525. Some customers prefer to use exclusively AMD processors over Intel. When discussing PowerFlex Rack, Appliance, and Ready Node, the majority of PowerFlex architecture is Intel-based. The R6525 specifically uses AMD processors. So for customers in that scenario, the only correct choice would be the PowerEdge R6525. The next section of the exam will test your knowledge at a functional level on PowerFlex objects, such as protection domains and fault sets, storage pools, storage data servers, and the metadata manager. You will be tested not only on your understanding of what each of these components do, but their various configurable settings and why you would need to manipulate them. You'll also be tested on operations involving these components, such as changing cluster ownership and entering and exiting maintenance mode, and the effects that has on the production environment. This is the second largest section of the exam, so be sure to have a solid understanding of these concepts. Now here's an example of a question asked for this topic. What is a benefit of using fine granularity storage pool? Is it compression, replication, deduplication, or encryption? The right answer is compression. Storage pools come in 2 varieties, medium and fine granularity. This question is testing if you understand the differences between the 2 types, specifically the fact that only fine granularity storage pools support data compression. This can be seen in the image of a medium granularity storage pool's properties. Compression is simply not available. Both types of storage pools support replication, deduplication, and encryption, so none of those features. The topic with the highest percentage of questions generated is the PowerFlex node and volumes configuration. In this topic, you'll be asked questions about the configuration of the PowerFlex nodes. The node configuration is initially designed when you use the PowerFlex sizer to gather different results based on the filters applied to the tool. PowerFlex sizer allows you to use simple and advanced filters to find the best results for the node configuration. As the design solution architect, you evaluate the results provided by the PowerFlex sizer. In addition to configuring the nodes, you're asked questions about the volumes implemented for the storage data requests. Volumes are gateways to the storage pool, the abstracted data block created from the servers participating as nodes in the PowerFlex cluster. Knowing how volumes are created, replicated, and protected is vital to an effective virtual storage solution. Lastly, in this topic, you're asked questions that pertain to the newest storage solution, file services. File services in PowerFlex 4.x is the implementation of a virtual storage solution that centers on file sharing or export protocols. Files provide multiple data sets in a single file or table for storage in a system of records. To implement file services in PowerFlex, you will need to know tasks and steps to maintain and create the service. Creating NAS servers is an important first step before the service is implemented. After the NAS server or set of NAS servers are created, you create file systems and share or export protocols depending on how the NAS server is configured. The options for the file system and share or export are SMB and NFS. Here's an example of a question asked about working with volumes. Which two remote protection configurations are available in PowerFlex Manager? Is it Pure Systems, Journal Capacity, Snapshots, or NDMP? Volumes are mapped to the SDC nodes in a PowerFlex cluster. The SDC node is the component that connects the client application request to the storage pool through the volumes. All the input and output data transfer use a TCP/IP connection. Of the four answers, Pure Systems and Journal Capacity are the two correct answers. They are the two remote protection configurations used to monitor and protect the data transfer from the storage pool to the volumes to the client application. Journal Capacity is used in a PowerFlex replication implementation. The source domain or source protection domain for the PowerFlex cluster is managed and operated by PowerFlex Manager. Once the SDR or storage data replication node is executed in the source domain, it provides the data from the source to a write journal that in turn sends the data to an apply journal through a TCP/IP connection. The write and apply journals are protected remotely through the respective journal capacity. The journal capacity is not controlled or managed by PowerFlex Manager. However, one PowerFlex Manager for that domain will now manage and operate how the data is transferred. The last topic covers PowerFlex solution integration, specifically for security. An example is the use of CloudLink to provide node data protection using node agents. The exam provides questions to qualify your comprehension of integrated PowerFlex security services. Also, working with a PowerFlex solution, a designer must understand that a design should meet customer expected results. A design has no control of errors that happen to affect performance results. To mitigate against unexpected results not related to the solution design, you need to know what logs are produced by PowerFlex Manager on the system performance. The log bundle is often a request by the Dell support services to help customers troubleshoot the system to help the designed solution meet expected results. Let's review an example of a question asked for this topic. What is the default location where CloudLink Center backs up its configuration data? Is it cloud storage, local desktop, object repository, or file system share.